Hi, welcome to Digital Electronic. Today I'm going to focus on the chapter number 5 on the flip-flop. Subtopic that involved in this chapter include none or non-latches, D-latch, active high, active low concept, H-trigger SC flip-flop, JK flip-flop, D flip-flop, and some of their applications. So in this particular chapter, you were able to identify the operation of positive H trigger and negative edge trigger of SC flip-flop, JK flip-flop, and D flip-flop. Describe the operation of SC flip-flop, JK flip-flop, and D flip-flop, and construct type of flip-flop using certain uh, logic circuit using drawing symbol, truth table, and also timing diagram. So in chapter 4 previously in the logical circuit, we have undergoes few example using circuit that only respond based on the present input. But in this particular situation, in chapter number 5, we're going to use the present input and also the past. So you're going to have a past over here, past input. So that means, let's say you have a circuit, so you have a input, you're going to have a output. This is the previously you have we done this one, but now we're going to have something we call pass. This pass will help or will change how the output will be obtained. So in the next slides, you can see over here we have we in the logical combinator circuit, you're going to have the input x and y, x and x1 and x0 and x1, and it's going in, do the analysis, do the process, and going to have the output over here. So but this particular situation in this, so when you have an input going in, so this input is not going directly to the output, so it's going to be going in here to the memory, check the memory, and come back to here, and by synchronize both of the information, and you're going to have a one output, which is the this is very important. So this particular situation will make this old circuit to become little intelligent, and it change based on the situation at that particular moment. So this is so latch are remembering only uh, one bit, and because of the either is a zero state or one state, and appropriate input can charge the state at any moment. But flip-flop, they have also zero and one state, but it can change state only when there is an appropriate input and the clock signal. So the word over here, clock is important because clock this determine when to change. So in the latch, you're only going to change anytime, but for flip-flop, you have a clock. This clock important to determine when to change. So you go for the first latch, which is none, and to just to make it sure, latch you cannot see any memory or any clock over here, so that means this is can change whenever it possible based only on memory. So basically the non latch is a very simple logic circuit, consists of two none. So your none is combining over here, and by using the feedback from the queue, so you're going to have a none. So this is the first none, this is the second none. You have a S over here. Sometimes we also call set. This one we call clear. Some books use the word R. You also can use C whenever you want. So I'm more comfortable to use C. So then I will use C on this particular work. So you're going to have a none, first none and second none. So the output of the first none is going to the queue, and then you're going to put as an input to the second none. So you're going to have a C and also a output of 1. And the output over here is going to be uh, X bar, and then it's also going back to as an input of set, input of the first none to become a. So we will go through this one later on. So this one is the okay, this inputs. So this will be input, and this will output. So there are some rules. Q, since Q and Q bar, so in this case your Q cannot be the same value as Q bar. So no, Q cannot be same value with Q bar. So if you have Q1, it must be 0, or you have 0, this may be 1. So this is a rule for here. So the situation is like this. So there are a few important steps that you need to know. So let's say in this particular latch, you have your S, you have your C, and you're going to have a Q. So we're going to build up a truth table for this particular situation. And since you are having S and C, you're going to have a situation where you have this S and C, and you are going to have a Q. And also, I would like to say that we're going to have a Q, and also you're going to have a Q bar. So I think this is too small. Okay, so let me draw again. So you're going to have a S, you're going to have a C, and you're going to have a Q. And this particular Q, you're going to have it output. So you're going to have an output of a Q. Okay, this one is a old Q. Let's say we put old Q and we put a new Q. So you're going to have a situation like this. Okay, so first usually we have 0 0, we have 0 1, 1 0, and 1 1. So this is the situation. Maybe so. So let's say we're going to have a 0 0. So the old Q, which is my I mentioned about earlier, I want to say here is Q equals to 0, Q equals to 1, Q equals to 0, Q equals to 1, Q equals to 0, Q equals to 1, Q equals to 0, Q equals to 1. And later I want to have this, I want to have this, this, and this. Okay, so let's say we don't we just ignore the first situation first. We go for the second situation first. That means 0 and 1. Let's say you're going to have a 0 over here, and this one is coming here. And don't forget, I have mentioned that you have a old Q. This old Q, you have two situations. Either is Q equals to 0 or Q equals to 1. So let's go for the first one, which is the Q equals to 0. Why I am putting 0 over here? This is a possibility that this 0 is already exited before this. They have a memory. So you have a situation where it might be the q is 0 before this. Before you change 0 1, they have a already result of q over here. So let's say we have 0. So when you have this one, okay, first you need to know the, so basically for none, you're going, you have a, you have b, you have z. So your z is a dot b bar. So your truth table is when you have a b 0 0 0 1 1 0 1 1. Oh, maybe a b c 0 0 0 1 1 0 1 1. So for 0 0, you're going to have 1, 0 1 is 1, you have 1 0 is 1, and plus you're going to have 0. So that is the, so let me draw it, make it more. A B Z 0 0 0 1 1 0 1 1. You have to have 1 1 1 0. So let's go for this one. This is none. Okay, two table for none. So when you have a 0 over here, you have 1 over, so 0 1. So you have a 0 over here, 1 over here, and q, let's say 0, so you put 0 over here. So now we are going to study the situation. So you're going to have a 0, 0 is going here. Because of here is 0, and the rule says q cannot be same with q1, so this will be 1. So right, so 1 over here will become 1 over here, 0 over here becomes 0 over here. So 0 1, 0 and 1 is 0 1 become have a 1. So the output of 0 and 1, they will be 1 over here. So this one will change to 1. And since this is already changed to 1, so this one is going here. This one is already changed to 1. 1 and 1 is 0. So you're going to have a 0 over here. So this one will become 0. And 0 is going over here to become 0. 0 and 0, you have 0 and 0 become 1. And 1 is still 1. And 1 is going here. 1 and 1 is 0. So you're going to have 0. So 1 is still having 0. And they'll go to 0. And this process repeat many times. But the final answer as at here, Q, is already changed to from 0 so you have a 0 over here, it's already changed to 1, so your output over here is 1. Okay, so this is already settled. So we this is how you get the answer for this situation. So now we able to repeat again, but this time we're going to put uh, q equals to 1. So q over here is 1, and since q is 1, so your q bar going to be 0. So 1, you just follow over here to be here is 1. 1 and 1, you're going to have a 0. So here it becomes 0. And over here, this is already 0. 0 and 0 become 0 and 0 become 1. And this one is going here. 1 and 1 become 0. Is always 0. And 0 and 0 is going to become 1. So that's why your final will become results of 1. So next we can follow these same similar steps. So over here now we're going for the third one, second one, 1 0. So you're going to put over here 1, over here this one is 0, this one is q is equals to 0. Then this, because q is 0, this is 1. So 0 0, this 0 is following here. Oh, I think 0 and 0, you follow the truth table. 0 and 0 is become 1, so this become 1, and this going up 1. 1 and 1, 1 and 1 is 0, so you're going to be 0. And then just follow 0 become 0, 0 0 become 1, and 1 is going up again. 1 and 1 become 0. So this process is endless, and we already achieved the maximum. So from 1, this one 1, this is 0, this is 0, and the final output is 0. So now we're going for the second one, 1 0. So you're going to have 1, you have a 0, and your q is 1. Because q is 1, q bar is 0. Let me put better 0. So 1 over here become 1, 1 0 become, this one will become 1. Over here is 1, 1 and 1 become 0, and 0, this one is already 0, 0 0 become 1, and this one is going here, and 1 1 is also a 0. So the process already matured. So when 1 and 0, you have 1 and 0, and q is 1, so the output of the final q will be 0. Next situation is the, you're going to have 1 1. So you have 1 over here, you have a 1 over here, your q is 0, and because q is 0, q bar is 1, so your 0 is going here. 0 1 is become 0 1, 0 1, 0 and 1 become 1, and over here is 1, 1 1 become 0, and over here come again 0, 0 1 is equals to 1, and over here 1 1 equals to 0. So your final results over here is going to be 0. So let's repeat this situation for q equals to 1. So your 1 is over here. So this s is 1, c is 1. So because q is 1, q bar is 0. So you have 1 over here, so this will become 1. This will become 1 and 1, you will have a 0. Going over here 0, 1 0, 1 and 0, you become 1. And again, this is already matured because 1 over here is going to be 1 over here, 1 1 0, this is also 0, and over here 1 0 will become 1. So your final answer for this new q is 1. as this one. So for this particular next one is 0 0. So you have a 0 over here, you have a 0 over here. Q equals to 0 and Q bar is 1. Okay, so you have a 0, so 0 0 is 1, and you over here is 1, 0 1 is 1, and you have a 1 over here, this become 1, and 1 0 become 1, and 1 0 is also 1. So over here, if you can see, it's already matured, and the final answer for q equals 0 0, q equals 0 is, the answer is, oh no. If you see over here, the final over here is 1 and the final over here is 1. So you, if you still remember the q and q bar, it cannot be the same value. So over here is 1, over here is 1. So you're going to have not a correct value. So that's why we call it over here invalid. So 0 0 and q is 1. Let's say we see have 1 over here, and since this is since this is 1, so it should be 0 over here. 1 over here, 1 0, 1 0 is equals to 1, and over here is 1, 0 1 is 1. If and 1, and if you see over here is going to be repeat again, this become 1 and this become 1. So the final answer over here is going to have uh, the final answer over here, you're going to have 1 and also 1 over here. So it's actually invalid. So the situation become where this is the truth table for this one. So if you see correctly over here, uh, the final answer of q for 0 0 is invalid. So invalid. 0 1, if you see over here, is always make 1 as a final. So 1 over here is also 1. So this we call set. And when there is 1 0, if you can see over here, is always 0. So we call over here clear. And because q is, when q is 0, the output of new q is also 0. When q is 1, its output is 1. So you can see it remain the same value. So because of it remain, we can call it whole. So this is, so this particular table has been simplified to this form. So 0 0, you're going to have an invalid. 0 1 is set. 1 0, you're going to have a clear, and 1 1 going to have a whole. So in general, this is your final or a simplified version of a AND gate latch, or also we call it SC latch. So when there is 0 0 is invalid, 0 1 is set, 1 0 is clear, and 1 1 is whole. So you can remember this one or memorize this one, or maybe you can go through step by step like this to obtain this particular truth table. So this is an example on how you're going to do when there is a timetable, or sorry, time diagram. So first you're going to have S and you're going to have a C. And when you have a situation like this, first analyze whether, where is your 0 and when is your 1. So you have a bottom over here, so this will be 0 and this become 1, this become 0, this become 1. So next step is to draw the intervals. So if you see over here, because since they have a interval like this, so just draw one big one. So same, similar to every possible places. And then later, the next step will be putting your one the value at particular area. So you're going to have 1110 because there is a drop, 1111 1111 011. So for C also 101110 1110. So you can see over here. Next, by using the truth table we generate, so please remember this one. So when you have a 00, it's an invalid, 01 is set, 10 is clear, and 11 is whole. So you just analyze step by step. So this is 11, so it should be whole, but the first step usually we will have a 0, and then second one 10. So S is 1, SC is 0, so I have 10. It is a clear, so you have a 0 checked. And then next you have 1 1. When you have a 1 1, so you need to have a whole. So what the meaning of whole here is remind the same value from before. So over here whole is to remind the same value. So before this it was 0, so just bring it over to become a 0. When you have 1 1, it is whole, and it's the value is from the beginning. The previous one is whole 0, it become a 0. If this is 1, this will become 1. It depends. This is latch has like that. So SC01, so you have 01 is a set, so you have 1. 1 1 is whole, so since the previous one is 1, so you're going to have 1 over here. 10 is clear, so you have 0. 1 1 is whole, so you have 0 over here. 01 is set, so you're going to have a set 1. 1 1 become whole, so you're going to hold the value, and 10 become clear, so you have 0. 1 1 is whole, 01 is set, you have 1. 1 1 is whole, to hold the value. Okay, so this is also same, and 10 is your clear, and that's why you have 0. So final results you're going to have, just draw 0 0 0 1 1 0 0 1 1 0 1 1 and 0. So this is your final answer. Right, thank you. Let's see the knowledge later on. Ah, so this is also a repetition of the same similar, so you're going to have the same, so you get, so please practice this one. Maybe this will be your own self study. Thank you.